Bismillahirrahmanirrahim. Today we will cover chapter 5 of our automotive technology course, that is brake system. I intend to cover this chapter in 4 parts. In first part we will learn the basic and then we will proceed further. So the basic slide of our this course as power flow train or power flow of from engine, where we have studied the power is developed in the engine in our IC course, then it goes to the flywheel and clutch, gearbox, transmission, propeller shaft, differential box, and distributed to the right and left wheels or tires, which we have studied. Now today's topic is brakes. So what is brake? Brakes are the foremost important mechanism on any vehicle because the safety and lives of those riding in the vehicle depends on proper operation of the braking system. It has been estimated that the brakes on the average vehicle are applied 50,000 times a year. So in average, in a year, it is applied 50,000 times. Brakes are an energy absorbing mechanism that converts vehicle movement into heat while stopping the rotation of the wheels. So brakes are an energy absorbing mechanism that converts vehicle movement into heat while stopping the rotation of the wheels. All braking systems are designed to do the following functions. First is to reduce the speed, stop a moving vehicle, and to keep it from moving if the vehicle is stationary. So all braking systems are designed to have the following three functions. First is the reduce the speed, stop a moving vehicle, to keep it from moving if the vehicle is stationary. Now let's see the pattern or the schematic diagram showing all the components of the brake. Now follow me. This is your brake pedal, and along with its linkage, it is attached to your vacuum power booster or any booster which boosts your this mechanical effort which you apply with your foot. So the brake pedal, the vacuum power booster, then we have a brake fluid reservoir, and then brake fluid reservoir we have this master cylinder. Master cylinder, then we have this combination valve. This is the previous one. In modern vehicles, we have the same assembly. This not a separate assembly, master cylinder and combination valve. Your master cylinder includes the combination valve. So we will study in detail in our part 2. What are the combination valves or what are their functions? So your hydraulic master cylinder includes the brake fluid reservoir along with these combination valves. From these combination valves, the brake line, then it goes to the front brake shoes, and front brake shoes are normally of disc type. We will touch upon that. So the path to the front brake or front tires is you have a brake pedal, then linkage, then your vacuum power booster. From vacuum power booster, you have hydraulic master cylinder, which has three parts: the brake fluid reservoir, the master cylinder, the combination valve, and then from that it goes to the brake lines or the pipes going to the front wheels. On front wheels, it goes to the caliper assembly or the disc brake. Normally in our vehicles, the front wheels are equipped with disc brakes. Now let's see what's happening in the rear. Same, we have a brake pedal here, then linkages, then vacuum power booster. They have hydraulic master cylinder, which is combination of brake fluid reservoir, the master cylinder, and the combination valve. And one of the pipe is going, the brake line is going to the rear wheels, that brake line, and it is going to the brake drums in the rear wheels. We will touch upon that. So this is the broad block diagram of a brake system in a typical vehicle. If examiner says to you that draw or write a block diagram of a typical brake system in a typical vehicle, then you have to write the block diagram for the front wheel and the rear wheel in this. For the front wheel, I repeat, you have a brake pedal. From brake pedal, it and one thing I missed, this is the brake warning light which is linked with your brake fluid reservoir or the hydraulic master cylinder. Its signal is indicated on your dashboard. So brake pedal, the block diagram will be like this. From brake pedal, the linkage, then the vacuum power booster, then hydraulic master cylinder. Then hydraulic master cylinder is a combination of three things: brake fluid reservoir, master cylinder, and combination valve. Then you will have two arrows, one for the front and one for the rear. In the front, you will write the brake lines and then disc brakes or the brake hose and disc brakes. This is front. Then from the hydraulic master cylinder, the other arrows, the brake line, and then going to the rear brake drums. Okay, both. Now, this is the simplest block diagram of a brake system which is there in the vehicle. Now, let's see one by one the disc brake and the drum brake. Now, front wheels are equipped generally with your disc brake. In disc brake, the major components are the rotor or a disc, which is rotating along with your wheel stud or wheel. Then you have the caliper assembly. On caliper assembly, then you have a bleed valve. And in caliper assembly, you may have a brake pads on both sides of this rotor disc or rotor. So caliper assembly is a main assembly which is having a bleed valve and a brake pad which are on the both side of this rotor. And this rotor or disc is attached to your wheel stud, and wheel stud wheel is attached to this studs. So this is the general description of your disc brake. Now going towards the rear drum brakes or rear brake drums, let's see what all are included here. Generally, we have this backing plate. Then we have a brake shoes, 1 and 2. One is primary and one is secondary. Then we have this wheel cylinder here. And then we have this anchor position and these return springs and the brake adjusters. So this is the description of a brake drum or drum brake. We will study in detail. And now one thing left here, the parking brake. We in the vehicle in beside the driver, there is also a parking brake. We have a parking brake handle. Then we have a parking brake adjuster. Then we have parking brake cable. And this is linked with your right and left rear drum brakes. Okay. So this is the path flow or the block diagram of a parking brake. You have a parking brake handle. Then you have a parking brake adjuster. Then parking brake cables, and that parking brake cables is going to your right and left drum brakes. So this is how you can describe the block diagram of a brake system in a vehicle. Now let's see in detail. I have already first the typical drum brake assembly. If this is the vehicle front here, so this green is your primary shoe and this green is your lining. Okay, and this blue portion is the metallic portion on which your lining is sticked. This green one is your wheel cylinder where the hydraulic force, the hydraulic pressure is applying, and with the help of when you apply a foot pedal, the hydraulic pressure is coming to this wheel cylinder, and this is moving these primary shoe and the secondary shoe stick to the drum assembly. So this is the point where both the shoes are anchored on the top, and on the down they are attached with this spring and the star wheel adjuster mechanism here. These are the return spring. When we apply the hydraulic force, they stick with the wall of the drum, the brake drum, and when we release the foot pedal, the hydraulic pressure goes back or dropped, and these return springs make them to come to their original position, and there is a gap. So this is the explanation of a typical drum brake assembly. Now coming towards the typical disc brake assembly, as I have already explained, this is your rotor or disc which is moving along with your wheel. This is your caliper assembly. These are the guide pins, brake pads on the both side, splash shield. Hydraulic pressure is applied to this caliper assembly, and this caliper assembly moves, and these disc brakes comes in contact with the rotor assembly, and they try to stop that rotor assembly from moving with the help of the friction lining material on the brake pads. So this is how the disc brakes works. Now, typical brake component system, another diagram. You have a brake pedal here and the power booster. It may be a vacuum power booster. It may be another power booster. Then you have a hydraulic master cylinder and hydraulic master cylinder. Then you have a brake warning light switch. Then on the front side, you have a metering valve, and on the rear, you have a proportioning valve. In the modern hydraulic master cylinder, these are part of this hydraulic master cylinder. So they are already incorporated in the master cylinder as shown here separately, but in now technology, they are part of the master cylinder here. So on the front, we have the metering valves, then we have a disc brake in the front, and then we have proportioning valve for the rear brakes, and then we have a drum brakes at the rear end. And same goes for the parking brake. We have a foot pedal here, then adjuster, brake adjuster, and the cable going to the drum brakes. Now, as we have already covered that there are two types of brakes. One is the drum brake and other is the disc brake. Drum brakes are used on the rear of many rear wheel drive, front wheel drive, and four wheel drive vehicles. When drum brakes are applied, brake shoes are moved outward. When drum brakes are, these brake shoes, this blue portion and green portion moves outward. The primaries goes in this direction and secondaries goes in this direction. When brake drums are applied, brake shoes are moved outward against a rotating brake drum. The wheel studs for the wheels are attached to the drum. So the wheel studs for the wheels are attached to the drum. When the drum slows and stops, the wheels also slows and stops. Here is the linkage. You can see a good clip on the drum brakes. Disc brakes. Disc brakes are used on front of most vehicles built since the early 1970s and on the rear wheels of the many vehicles. Now in modern technology or in this latest era, all wheels are equipped with your disc brakes. Instead of drum brakes, we are now using disc brakes on all the four wheels of a vehicle. A disc brake operates by squeezing brake pads on both sides of the rotor or disc that is attached on the wheel, as I already explained. So these are the brake pad, one on this side, one on the other side. With the hydraulic pressure, they comes inward and they stop this rotor for moving. And on this rotor, there are wheel studs which are attached to your wheel. So the wheel stops like this. And this is the link. You can see a good video clip. Moreover, I have already uploaded these video clips. You can watch on my channel. Very simple, very illustrated video clips which gives a clear understanding regarding the drum brakes, disc brakes, how the brake master cylinder works, how the car brakes works, and how the parking brake works. Now, brake design requirement. If you are, if being a mechanical engineer or automotive engineer, if you have to design a brake, what are the brake design requirements? So all braking force must provide for the following. Equal force must be applied to both the left and right side of the vehicles to assure straight stop. Suppose you design a brake, but that is not equally applying on the left and right side. If it is applying more on the left side and less on the right side, so your vehicle will pull on the left side, or you may be topple the vehicle. So equal force must be applied to both the left and right side of the vehicles to assure straight stop. Hydraulic system must be properly engineered and serviced to provide for changes as vehicle weight shift forward during braking. Your hydraulic system should be properly designed. Each and every force must be catered for. The weight should be catered for. When you are moving, the vehicle is moving. Initially, when vehicle is standing, you have a static load. But when vehicle is moving, it becomes a dynamic load. So when you stop that dynamic load, the weight, the center of gravity shifts. So your hydraulic system must be engineered and serviced like this. So it should cater for all these changes. So hydraulic valves must be used in the hydraulic system to permit the maximum possible braking force, but still prevents undesirable wheel lockup. So your hydraulic system and especially the hydraulic valves should be designed and to have some such braking force that to provide the undesirable wheel lockup. Normally, a vehicle equipped without anti-lock braking system or ABS system, we have this wheel lockup problem in those vehicles which are not equipped with ABS system or anti-lock braking system. Anti-lock braking system, ABS, are specifically designed to prevent wheel lockup under all driving conditions, including wet or icy road condition. So what is wheel lockup? When you're driving a vehicle which is not equipped with ABS system, you apply a brake, the brake pedal works and your brake system works, and it's get hold of that brake drum or the rotor, and they are locked. When they are locked, your wheel skids on the roads. That is the wheel lockup. Okay, but if you are using a vehicle which is having a ABS system, anti-lock braking system, in which wheel lockup problem is not there. It gives you pulsation. When there is a pulsation, there's wheel is not locked. We will study this anti-lock braking system in part 3 of this chapter. The hydraulic system must use a fluid that will not evaporate or freeze. So the hydraulic engineering, the hydraulic fluid which you are using, it should not be that such that it should evaporate or freeze in extreme conditions. The fluid has to withstand extreme temperatures without boiling and must not damage rubber or metal parts of the braking system. So it should not be harmful to the rubber parts, the rubber pipes which you are using, the rubber caps which you are using, the rubber seals which you are using in the hydraulic system, and it should not damage the metal parts also. It should not get corroded. So hydraulic fluid should be not evaporate or freeze, withstand extreme temperature, and it should not damage the rubber or metal parts of your braking system. The friction material, brake shoes or brake pads. The friction material which we are using on the brake shoes or brake pads must be designed to provide adequate friction between the stationary shoes. So that friction material, the lining material, should be such like that it should provide adequate friction between the shoes. Now, the categories of the brake system, how we categorize the brake system. Previously, it was the design requirement, equal force, hydraulic system, hydraulic fluid, and the friction material. So we have to cater all these design parameter into consideration while designing a brake. Now we can divide the brake system categories into 6 subparts. First is the apply system. The driver starts the operation of the braking system by pressing on the brake pedal or applying the parking brake. So this is your application system or applying system. The driver starts the operation of the braking system by pressing on the brake pedal or applying the parking brake. The apply system includes all the lever, pedals, or linkages needed to activate a braking force. So the apply system includes all the levers, pedals, or linkages needed to activate a braking force. This is your apply system. Now, after the apply system, we require to enhance that force. To enhance that force, we require some boost system. So the power brake system is used on most vehicles to reduce the force that the driver must exert on the brake pedal. So in order to reduce or minimize the driver effort, we require some boost mechanism or the power brake mechanism that should reduce the force applied by the driver. So the boost or the power brake system is used on most vehicles to reduce the force that the driver must exert on the brake pedal. After the boost system, then we require a hydraulic system which should enhance that force and get the job done. The hydraulic system, the brake pedal force is transferred to the hydraulic system where the force is directed through lines and hoses to the wheel brakes. So after applying system, the boost system we require some hydraulic system that transfer that force to the hoses, lines, and then to the wheel brakes. So after that applying system, boost system, hydraulic system, the wheel brakes comes in. The hydraulic pressure from the hydraulic systems moves a piston in either a disc or a drum brake system, which uses friction to press material against a rotating drum or rotor. The resulting friction slows the rotation of the wheels. So in the wheels brake, that hydraulic pressure which we are getting from the hydraulic system after the apply, boost, and hydraulic system, the hydraulic pressure from the hydraulic system moves a piston in either a disc or a drum brake system, whichever you are using, which uses the friction to press material against a rotating drum or rotor. That the brake pads which you are actually using, the lining material which you are using, is pressing the rotating drum or a rotor. So the resulting friction slows the rotation of the wheel drum. Now, after that, applying that brake and the brake system, the wheel brake, the brake balance control system is required. So the mechanical, electrical, and hydraulic components are used to ensure that the brakes are applied quickly and with balanced power pressure for safe operation. So brake balance control is the utmost important thing, that mechanical, electrical, and hydraulic components are used to ensure that brakes are applied quickly and with balanced pressure for safe operation. If the pressure applied is not balanced, then we have serious consequences. Components in this category includes the metering valve, the proportioning valve, and the anti-lock braking system components. So these are the five main categories for the brake system, and sixth one is the brake warning lights. There are two brake system related warning lights. First is the red brake warning lamp RBWL lights. Whenever a hydraulic system failure occurs, the red brake warning lamps lights when the ignition is turned on as a bulb check then goes out unless a hydraulic fault has been detected. This is on your dashboard screen. And in second case, the amber ABS warning lamp or dim red brake light indicates an ABS self-test and or a possible problem in the ABS system. This warning light will usually flash several times during a self-test when the engine is first started and then go out unless a fault with the anti-lock braking system was detected. So there are two types of warning indication, brake warning indication lights. One is the red brake warning lamp and second is the ABS warning lamp. So these are the six brake system categories. First is the apply system, boost system, hydraulic system, wheel brake system, brake balance control system, and brake warning lights. Now, let's see more about the drum brakes. Drum brakes, the advantages, it is self-energizing and servo action. The primary advantage of drum brake is that they can apply more stopping power for a given amount of force applied to the brake pedal than can disc brake. How it is so? Because of the large surface area in contact of the brake shoes. The primary advantage of drum brake is that they can apply more stopping power for a given amount of force applied to the brake pedal than can disc brake. This is possible because the drum brake's design offers a self-energizing action that helps force the brake lining tightly against the drum. In addition, some drum brakes designs use an effect called servo action that enables one brake shoes to help apply the other for increased stopping power. As we have seen in the drum brake, there are two shoes. One is the primary, one is the secondary. So both are helping each other. So in addition, some drum brakes designed use an effect called servo action that enables one brake shoe, the secondary brake shoe, to help apply the other for increased stopping power. Now, in case of parking brake, one advantage of drum brake is that they make excellent parking brakes. A simple linkage fitted to the handbrake assembly allows relatively low effort from the driver to hold a heavy vehicle in a place when parked. So drum brakes are usually used for your parking brakes in old vehicle. Now, due to advancement in the technology, we have electronic parking brake system, and we will study later on this thing. Drum brake disadvantages. Brake fade. First disadvantage is the brake fade. Second is the brake adjustment, and third is the brake pull. So let's see what is the brake fade. What type of disadvantage it is. So brake fade is the loss of stopping power that occur when excessive heat reduces the friction between the brake shoes lining and the drum. There are four types of brake fade. I read again. Brake fade is the loss of stopping power that occurs when excessive heat reduces the friction between the brake shoe lining and the drum. There are four types of brake fade. First is the mechanical fade. Mechanical fade occurs when the brake drum gets so hot it expands away from the brake lining, dropping the pedal due to this. So mechanical fade is that Mechanical fade occur when the brake drum gets so hot it expands away from the brake lining, dropping the pedal due to this. So there is a more gap between the brake lining and the drum. So that gap is not when you apply a full brake pedal and still there is a gap, that is a mechanical fade disadvantage. Lining fade. Lining is the basically material on the brake shoes. The lining fade occurs when the friction coefficient of the brake lining material drops off sharply because intense heat makes it slippery, pedal becomes hard. So that material which is used on the brake shoes is the lining material, and the lining fade occurs when the friction coefficient of the brake lining material drops off sharply because intense heat makes it slippery. So due to lot of heat, the friction coefficient drops and it makes it slippery. Pedal becomes hard. Gas fade. Third fade problem is gas fade occurs under extended hard braking. From high speeds, a thin layer of hot gases and dust particles can build up between the brake shoes lining and the drum. So, because there is air inside, so that air and the heat, lot of hard braking that converts into hot gases and dust particles, and that can accumulate between the brake shoes and the lining and the drum. So gas fade occurs under extended hard braking from high speeds. A thin layer of hot gases and dust particle can build up between the brake shoes lining and drum. Water fade. Water fade occurs when moisture is trapped between the shoes and drums where it acts as lubricant, lowering braking efficiency. Sometimes it is moisture or sometimes the water is entrapped inside while crossing some flooded area, or some water can seep in from different side if it is not properly fitted. So the water fade occurs when moisture is trapped between the shoes and drum where it acts as a lubricant, lowering braking efficiency. So first disadvantage is the brake fade, and in brake fade there are four types of brake fade: mechanical fade, lining fade, gas fade, and water fade. Now the second disadvantage is brake adjustment. Another disadvantage of the drum brake design is its needs for an adjusting mechanism. As the brake shoe lining material wears, the clearance between the lining and the drum increases, resulting in a longer brake pedal travel. So the lining material thickness drops because of the wear. The clearance between the lining and the drum increases, resulting in a longer brake pedal travel. To maintain a high brake pedal, a mechanism must be included in the brake assembly for adjustment of clearance between the brake shoe and drum. So, to maintain a high brake pedal, a mechanism must be included in the brake assembly for adjustment of the clearance between the brake shoe and drum. Most vehicles have automatic adjusters in nowadays that maintains the proper drum to lining clearance. So most vehicles have automatic adjusters that maintains the proper drum to lining clearance. The gap between is fixed then. Brake pull, the third disadvantage. Brake pull occurs when the friction assemblies on the opposite sides of the vehicle have different amount of stopping power. Because we are using the lining material, the friction properties change, so that due to friction properties change, the brake pull occurs. The brake pull occurs when the friction assemblies on the opposite side of the vehicle have different amount of stopping power. So these are the three disadvantages of the drum brake. Now let's see the figures of the drum brake part in parts. First, this is the backing plate. The backing plate is the foundation of every drum brake. There are normally 6 pads where the brake shoes contacts the backing plate. So this is the backing plate, and this is the anchor point on which we have the primary and the secondary shoe, and these are the mounting holes. These are the shoe support pads, and this is the curved lip on the end where the drum is fixed. So this is the backing plate, which is the foundation of the drum brake. Now, a shoe, a keystone anchors allows the brake shoes to self-center in the drum. So let's see, this is your brake shoe, the backing plate. This is the anchor where it is hold drum brake. This is the drum brake. This is shoe. This is the drum brake. And this is the brake shoe. This is the primary and this is secondary. This is the return spring and this is the anchor position where it is. A keystone anchor allows the brake shoes to self-center in the drum. Now, piston stops prevents the wheel cylinder from coming apart. So this is your wheel cylinder, and this is the shoe's anchor, and this is the reinforcing plate, and this is the backing plate, and here we have the shoes, and the piston stops prevents the wheel cylinder from coming apart, so it may retain its to its original position. Then the cross sectional of a wheel cylinder that shows all of its internal parts. The brake line attaches to the fluid inlet. The cup extender prevents the cup seal lips from collapsing when the brakes are released. So the brake line or the brake fluid is coming from the fluid inlet. Coming here, we have a piston springs here. Then we have a piston on the both side. We have a cup seal here on the both side. Fluid is coming with, with pressure here, and it is forcing when we press the pedal, the fluid comes with the pressure and moves the piston outwards. It's push rods. So they energize the primary and the secondary shoes. Okay. So this is the portion where you have a fluid. When we press the pedal, the brake fluid comes with the pressure, less of space, the spring is there, it forces the piston outward, the push rod goes out, and it energizes the shoes. When you release the foot pedal, the hydraulic pressure drops and this return springs closes and the piston comes back to its original position. Now, the push rods are held in place by a rubber dust boot. So this is your wheel cylinder. These are the dust boots, and these are the push rods which are moved. These wheels shoes brake. The push rods are held in a place by the rubber dust boots as the wheel cylinder piston moves outward. The push rods transfer the movement to the brake shoes. Then the typical drum brake shoe and the name of the parts. So this is your complete brake shoe. This here we have an anchor end. This portion is known as rim. On the surface here we have this coefficient of friction, formulation, friction material. These are the lining friction material, and this is the metal portion. We have a web and weld here, and this is the adjustment end here. So, and then the primary forwarding face. This is the primary forwarding facing brake shoes often has a shorter lining than the secondary shoe rearward facing. The color of the primary and the secondary lining can also be different due to difference in the friction and wear requirement. So this is your primary shoe and this is your secondary shoe. And this is the metal portion and this is the primary lining. It is of smaller size as compared to your secondary, and the color is a change in both and due to the friction and wear requirements. Now incomplete, a typical drum brake assembly sporting the showing the support plate. This is the support plate, the back plate, the foundation plate. Then this is the leading shoe or the primary shoe, and this is the secondary shoe. This is the anchor position. This is the wheel cylinder, the return spring, the adjuster mechanism. Okay, these are these stirred and the spring, leading shoe, trailing shoe, adjuster cable, and adjuster mechanism. So this is the typical drum brake assembly showing the support plate, backing plate, brake shoes, and the springs adjustment. What all is there. Non-servo brake design. Purpose and function. A non-servo brake feature is that each brake shoe is applied individually. The action of one shoe has no effect on the action of the other. Many non-servo drum brakes use self-energizing action to improve their braking performance. Parts and operation. A self-energizing action occurs when the forward or leading shoe contacts the drum and the drum attempts to rotate the shoes along with it. However, the shoe cannot rotate because its far end relative to drum rotation is fixed in a place by an anchor. As a result, the drum rotation energizes the shoe by forcing it outward and wedging it tightly against the drum brake. So this is how the non-servo brake operates. Non-servo brake design. Self-energizing action can increase or decrease the stopping power of a brake. So we have a direction of rotation here in this counterclockwise direction. So this is the leading shoe, energizing shoe, primary shoe. Here shoes are anchor. This is the return spring. Trailing shoe, de-energizing. So it is energizing. Leading shoes is energized and trailing shoe is de-energized. So this is the non-servo action. Brakes hydraulic system. Master cylinder is the heart of the entire braking system. No braking occurs until the driver press the brake pedal. The brake pedal linkage is used to apply the force of the driver puts into a closed hydraulic system that begins with the master cylinder. No braking occurs until the driver depresses the brake pedal. Let's see. Master cylinder operation. The composite master cylinder is made from two different materials, aluminum for the body and the plastic material for the reservoir and the reservoir cover. This type of reservoir feeds both primary, closest to the driver, and secondary chamber, and therefore uses a fluid level switch that activates the red dash warning lamp if the brake fluid level drops. So this is your reservoir cover, then you have a diaphragm, then you have a reservoir, and then this is your fluid level switch, which indication is on your dashboard. This is the grommet, and this is your cylinder body, the composite master cylinder. This portion is made of your aluminum portion, and this upper portion, the reservoir portion, is made of your plastic material. Master cylinder operation. Note that the various names for the vent port, front port, and the replenishing port, the rear port, names vary by vehicle and brake. Component manufacturers. The name vent port and the replenishing port are terms recommended by the Society of Automotive Engineering SAE. We have this master cylinder, the composite one. Here, this portion is your reservoir and this portion is your aluminum body. Here we have the piston rod. The vacuum power booster is here on this side. When we apply a brake pedal, the vacuum power booster pushes this piston rod inside. Then we have this 1 and 2, the vent hole and the replenishing hole. Initially, it is like this. Fluid is coming here. fluid is here. When we apply the mechanism, it closes this vent hole. The replenishing fluid comes here, apply pressure there, and this pressure fluid which is entrapped here is pressed, and force pressure is maintained here and then goes to the fuel lines. Vent ports, also called compensating ports or bypass ports. Replenishing ports, also called inlet ports, bypass port, filler ports, or breather ports. So let's see the working of the master cylinder. The vent ports must remain open to allow brake fluid to expand when heated by the friction material and transferred to the caliper and or wheel cylinder. As the brake fluid increases in temperature, it expands, causing the brakes to self-apply, which is prevented by the open vent ports. In normal condition, we have these vent ports here, and this is your replenishing ports. So there are two outlets here. One is going to the rear brakes and second is going to the front brakes. These are the piston cups, primary piston cup, secondary piston cup. So in normal condition, this is like this. The vent port is open. Now, as the brake pedal is depressed, the push rod moves the primary piston forward, closing off the vent port. So as the pressure pedal is depressed, the push rod moves the primary piston and it closes the vent port. Then the spring is compressed and the secondary piston is also moved and it blocks the other vent port. Okay. So as the brake pedal is depressed, the push rod moves the primary piston forward, closing off the vent ports. As soon as the port is blocked, pressure buildups in the front of this primary sealing cup, which pushes on the secondary piston. The secondary piston also moves forward, blocking the secondary vent port and building pressure in front of the primary sealing cup. So you depress the pedal, from then vacuum power booster, and then comes to the force comes to this primary piston. It presses it, compresses it. This spring and the fluid is pressing this secondary piston, closes this secondary vent, presses it, and the pressurized fluid is now going to the rear and the front brakes. Now, when we are depressing the pedal, the vent port is locked. The purpose of the replenishing port is to keep the volume behind the primary piston filled with brake fluid from the reservoir as the piston moves forward during the brake application. So the fluid coming from the replenishing port in back of the piston here. So all this is filled with the hydraulic fluid here. Now let's see what happens. When the brake pedal is released, the master cylinder piston moves rearward. So it moves backward. But here we have the replenishing fluid here. So what happens to the replenishing fluid there? Some of the brake fluid is pushed back up through the replenishing port. So some of the when this is going back, some of the fluid goes back to the replenishing port. But most of the fluid flows past the sealing cup. But most of the fluid flows past this sealing cup, this piston surface and this sealing cup. Therefore, when the driver pumps the brake pedal, the additional fluid in the front of the pressure building sealing cup is available quickly. So some of the fluid is going back to the replenishing vent and most of the fluid is going past the sealing cup here, and you are readily available the replenishing fluid here. So it will help you quickly building up the pressure here. So with this, we comes to the first part of our chapter 5, that is brake. We in next part we will cover more regarding the brakes. Thank you very much.